Good day to Dr. Tutut, and today we will presenting on the topic of big data practice in Tripadvisor, big data analytics for hotel reputation management and sentiment classification. My name is YuJie. Our group is Group 3. I'll now pass the slide to YuJie.
The first part is storage big data resource. First, for the environment, we automated the setup on the Google Colab with Java and PySpark and scan the memory to 4 GB to ensure the stability with the big data. Second, for the data ingestion, it's fully automatic. As shown in the center, we replace the manual uploads with the Kangol API, and our script automatically locates the CSV files and feeds them into the Spark engine, which saves us a lot of time. Next one.
Hello, Doctor. So here we're going to be talking about the natural language processing that we've used in our pipeline. The main problems that we noticed was that we had contextual ambiguity, which is where isolated words lose their meaning, the data sparsity, which is in relation to the sentiment differing between the review title and the body, and we also have high dimensionality in noise, which is where you have single stop words or singular words such as not good, which are losing their predictive power. So our solution here was on data fusion. So we are concatenating the review title and the body to preserve the sentiment and handle the null values, which are relevant. Context preservation, so implementing n-gram transformers. So we have bigram, trigram, and also singular n-grams to capture sentiment in more detail. And ideally, this gives us a clean regex alphabet, which removes the non-alphanumerics, which include issues such as the translation and emojis and any numbers that were relevant in the data. And that leaves us with the vectorized output to penalize noise and boost specific terms.
So this is the pipeline for sentiment analysis. So initially we have about 800K review. Then we punch into Apache Spark. So the first step we have about processing reviews back from the HDFS. Then after that we change it to unstructured data to structured data. So from the structured data, we convert it to bigrams, unigrams, as what I mentioned earlier. So we can capture the keywords like customer service instead of single words. So as far as we already sort them to negative and positive. So negative, we have about 1 to 3 star rating, and positive about 4 to 5 star rating. So we don't have neutral in this case because we want a driving indicator. Okay, so for performance, we see that the model actually significantly better when identifying positive review than the negative one. Overall score is about 0.9104, which is a strong and balanced model across both class. And for evaluation, we've seen this is the metrics, negative review about this score and positive review about this score. So as you can see, the positive is slightly better here. Okay, moving on. We will see this is the next model. This is on the topic modeling using clustering. So the objective here is actually to extract the complaint themes from about 1,000 unstructured negative review, so less than 2. And you can see from the mass data here, we struck to topic A, topic B, topic C. So the methodology here is very simply, start from the LDA, we use PyStark, and then we expectation maximizer optimizer. Then remove the domain specific for foreign words. Then we perform a grid search. So starting from K6, then moving on to 8, then 10, then 12. But the best on the results we've seen is actually 10. And then this is actually the evaluation of the keywords. So this is picked from on the list of vocabulary based on the corresponding complaint category. Okay, next. This is on linear regression, LDA topic features. So after we have done the 2 models, we have actually run through the data frames, and here we do is to do the ranking of the reviews. Okay, so here the goal is to predict aspect level ratings from review text, derived features such as service, etc. Then we convert this to fine-grain the overall star rating. So for data and features, we filtered down the reviews to null aspect ratings. And for features, we have the LDA topic distribution vector, which converts to numeric. After that, our strategy here is to apply the linear regression model per aspect. And of course, the test train split is 80-20. So based on that, our performance we get is here, service about 1.01 for RMSE, 0.15, cleanliness, this, the value, this is the top, I guess, top aspects. And then from the interpretation here, we can see that LDA provides a useful but limited signal and low R squared across all model. And we have the more than topic proportion, and then these are the examples. So some of the good implications is that they provide direct insights, not just on scoring alone. Then we also can improve the data. So we add metadata and nonlinear model, and then also the sentiment features to capture the subject. Thank you, and I'll move on to the next presenter.
Okay, thank you, YuJie. So here are our visualization parts by Power BI. Quick introduction, the dashboard structure is like a story. The EDA overview to sentiment summarize to topic overview to prediction. So it's easier to follow. So about our data, we export the data file that we need from Colab each part, but some file sizes are very huge, so I use HIVE first to simplify it. Just keep only the useful value. Export as a CSV form and also use DAX metric in the Power BI. So now could you please change to the dashboard? Yeah, the online link. Okay, so on the top we have hotel ID and the time range. So when we pick one hotel, the whole page will change it together. And the next page, please. Yeah, this page is about predicted positive rent and model confidence and comparison with renting derived sentiment. Okay, next page. So at this page, we can see which topics appear the most and also show many negative reviews are about very dictated problem, like bathroom, dirty and small. So there are strong signal for hotel improvement. Okay, the last one. Okay, so here we show prediction error and actual values predicted by a topic. So we can see which topics are hard to predict. Yep, that's my part. Okay, switch to the slide. Okay. I'm finished already.